Hi guys. So, have you ever wondered what exactly are polynomials? So, most of you find this a bit complicated. So, I can assure you by the end of this video, you will understand the concept of polynomials quite well and will be in a capacity to solve any problems relating to polynomials. All right. So, let's take step by step explanation of the definition. Polynomials are algebraic expressions, right? So do you know the meaning of algebraic expressions? So let me break it up, by and by. So algebraic expressions are all those terms which are bound by either plus, minus, multiplication or division. I'm sure you will not understand this because this is a bit abstract. So let me take you through examples. Say we have 7x plus 3. So this is an algebraic expression. Alright. Since we have a plus over here, this is first term, this is a second term. It can be say 3x minus 2, x square plus say 14. Alright, a mixture of pluses and minuses, right? Pluses and minuses. There can be multiplications also. Say if I say 7x plus y square. So even this is an algebraic expression. Now what about the next feature of a polynomial? So it always has a non-negative integral powers. Integral as in integers. And integers, you all know that on a number line, if we have a 0 here, 1, 2, 3, all positive numbers extend infinitely on our right hand side, and all negative numbers stretch infinitely on our left hand side. There will be 1, 2, 3 and thus. Here too we have minus 1, minus 2, minus 3 and it just goes on. Another feature of an integer is that you will never find it in a fraction other than say 3 by 1, 2 by 1, 1 by 1. Alright. So that also you got to remember that it will have powers always as non-negative integral powers. This will become clear if I give you an example of a polynomial. Remember guys, poly means many. So it comes in many shapes and sizes. Even a 3x is a polynomial. A kind of polynomial which we refer to as monomial. If we were to write say 3x square plus 7, this is also a kind of polynomial, right? This has got two terms, so we can call it as binomial. If this was to be extended more, then we would call it a trinomial, and so on and so forth, right? So what is important for us to know, how do we distinguish from a polynomial and others which are not polynomials? Polynomials has to have non-negative integral powers. For example, we have 2 here. We have a power of 1 here sitting with x. Say px. This is a polynomial in one kind of variable of x, right? Here we have a constant, which means we have an invisible x which has a power of 0. Now you may be wondering that this is non-negative or not? Okay, so is this negative or a positive? No, they are non. Okay, of them. Okay, so in this case we know that x has a power of 0, which means in integer, which is sitting over here, we call this neither positive nor negative. Whereas the disclaimer over here is non-negative, means only the negative exponents, negative powers are out. They are restricted from being utilized in a polynomial. For example, if we have 7x cube plus 4x square, okay, minus 2x, okay, and plus 5. All right, so this is also another kind of a polynomial, which is, okay, of one variable, which is x, and this is a positive exponent, positive power, and here also a neutral power, a neutral integer. Correct? Now if we were to given, okay, to find out whether this is a polynomial or not, what would you say? Is this a polynomial? If we were to expand this, we would write p to the power half, am I right? And 5 to the power 5 and x to the power 0. Correct? So here we have 1 upon 2 as a power, and 0 is welcome, right? So 0 could be there, but we will not accept half or any fraction or any rational number here in a polynomial. So this is not a polynomial. All right. So if I were to give another example, say x cube plus 1 by x square plus 7. Here we have 3. But what about this? Because when we simplify this, this becomes x to the power 3 and this becomes plus x to the power minus 2. And this 7x to the power 0. Alright. So can we accept this? This is a negative integral power and we do not want, okay, any negative integral power. We want non-negative, okay, integral powers, non-negative integers in the power. Correct? So this is not a, so I would say not a polynomial, and for this also not a polynomial. Correct? Now I'll give you another wonderful example, okay, for you to decide whether this is a polynomial or not. Alright, so what about this? So this is example 1, this is example 2, this is example 3. Alright guys, so what about this? Is this a polynomial according to you or not? So let me just explain you. This is a polynomial, and how I'm going to prove it? By simplifying further. So since we have a common denominator, so can we not write this? We can do that, right? 2x upon x, right? So they get cancelled, and what are we left with? Okay, 4x to the power 3. 4x to the power 3, here x to the power 2, and here just 2. Got it or not? So this has got a non-negative power. This 2 also has, and this has x to the power 0. As a result, this is a polynomial. Correct? So this is the way we decipher, we try to distinguish between a non-polynomial and a polynomial, so that there is clarity in your mind what polynomials exactly are. So I hope we have been able to decode polynomials, okay, in our favor, so that in future if there is any such questions, you are confident enough to crack them all. Okay, so having decoded this, we'll have some more, okay, decoding done in the near future. So guys, wait for some more videos coming up soon. Bye bye till then. Have a great day.